In the last lecture, graph coloring part 2, I have discussed explicit constraints, implicit constraints and state space tree for graph coloring problem. Also, I have discussed the function next value k for a given value for a given vertex k, which is the bounding function for graph coloring problem. Today I will give the main backtracking algorithm which uses this next value function as a bounding function. Okay. So now the m coloring function is m coloring m coloring k while true, and first it will generate the next possible color by calling the function next value k, next value k, and if this function return 0, like xk equal to 0, it means no new color is possible. If xk equal to 0 means no new color is possible and it will come out from this outer while loop. So here I am writing break. If k equal to n, it means the color for all the vertices have been decided. Now it will print one solution, write x1 so on xn, else m coloring k plus 1. This is while loop and this is our main algorithm, and this algorithm is called from the main with the value of k is 1. So from main this function will be called as m coloring 1. Okay. So now we can I will write m coloring 1. So here the value of k is 1. But before calling this function, first you have to read graph, and the graph is stored in the adjacency matrix, what I told earlier in part 2. Here I am writing the main function. If you are going to implement it, main, and then simply you read the function g read. Here the graph is declared globally. Graph int g 10 10. This is declared globally, and the solution vector is also declared globally. Okay. Now the gread function is called to read the graph, and after reading the graph will be stored in the adjacency matrix, and then simply this n is also declared globally, which is the number of vertices. Okay. Gread, and then this will call m coloring 1. This is the main function. In the main function, the graph g 1 to n, that is where n is the number of vertices, 1 to n number of rows and n number of column, and the x is a solution vector 1 to n. Okay, and n is number of vertices. N is number of vertices. x1 to n is a solution vector which is declared globally, and before calling this function, one more line is missing here. Before calling this function, you have to initialize the solution vector with 0. for I equal to 1 to n, xi equal to 0. I is equal to 1 to n, xi equal to 0. So the solution vector first initialize with 0 and then you call m coloring 1. This is the main function. Okay. Now I will dry run or trace this m coloring function. If you compare this m coloring function with the general backtracking algorithm, here next value k is a bounding function which is simply generating the next highest possible color. If no new color is possible, which is not feasible, then just this break, it will come out from the outer while loop and the next value will be popped or the next color will be checked. Okay, for the vertex adjacent to k. So now I am giving the dry run of this algorithm. Okay. So first from the main, this function I will call as k equal to 1. When I will call m coloring k equal to 1. Okay. While true, the condition is true. Here the outer condition is true. Condition is true. And the function is called next value k. So here the control is transferred here next value k. Simply this here I am just tracing the next value k function. This is next value k. So here the value of k is 1 and I am taking the graph as this one. The graph is this 1, 2, 3, 4. This is the graph and the number of colors m is 3. Okay, m is 3 and solution vector x. Here I will write the solution vector x. Solution vector x initialize with what? 0, 0, 0, 0. 1, 2, 3, 4. Okay. This is our graph. Example graph. Number of colors are 3. Value of n. Number of vertices are 4. And this is the solution vector and initial value of solution vector. So next value 1. Next value 1 is called, the control is transferred here. Now see the working of this function. K is 1. Here I am just dry run it with the table. K equal to k. K is 1. K is 1. This condition while true. While true. This is the infinite loop. So this condition is true. Now next it will compute this expression. The new value, the next value of xk. Okay. So next value of xk is what? While true is true. The next while true xk, that is xk equal to xk plus 1 mod 4. Mod 4 because when the value of m is 3. So mod 4. So here the value of k is what? 1. So x1 equal to x1 plus 1. Value of x1 is 0. 0 plus 1 mod 4, that is 1. Okay. So now this x1, value of x1 is not 0. So this condition is false. Now the value of flag. Here I am taking one row for flag. Flag is what? 1. Flag is 1. flag is 1. Then the loop will run for j is equal to 1 to k minus 1. So it will run 1 to k minus 1, that is 1 to 0. So this loop will not run. The value of flag is still 1 and this is break. So it will come out from the outer while loop. So here now the value of xk, that is 1. There is a new updated x vector is what? 1 0 0 1 2 3 4. Now xk, x1 is not equal to 0, k is not equal to n. The function will be called m coloring k plus 1. So now here, because this is a recursive algorithm, so stack is maintained. Okay, so now the stack is maintained and simply here say suppose I am having the stack, stack is this is the stack. Okay, stack. Okay, and this is stack. Okay, so before calling this m coloring k plus 1, the current value of the local parameter in this function, there is no formal parameter, and as all you know, whenever there is a recursive call, all local and formal parameters are pushed onto the stack. So here there is only one local parameter k. So before calling this function, the current value of k is pushed onto the stack, and which is 1. At this time the value of k is 1. So the 1 is pushed onto the stack. Now the function is called m coloring k plus 1. So the new value of k is 2. Now the new value of k is 2 while true. Next value 2. Now this function again will be called, but now this time the value of k is 2. Okay, the value of k is 2. So again see the working of this next value with value of k is 2. K is 2 while true. The condition is true as this is what? The infinite loop, true. Okay, and then x2 here, x2 equal to x2 plus 1 mod 4. Okay, so x2, what is the value of x2 here? The value of x2 is 0. So 0 plus 1 mod 4 is what? 1. So now the x2 is 1. So simply just here in the x vector, this is updated 1 1 0 0. Okay, now the x2 is 1. Now simply just it will check. This is our graph. This is our graph here. 1 2 3 and 4. Okay, and k equal to 1, and now at this time its value is 2. So 1 is colored with this one, and now simply this here, this piece of code, simply this line will generate the next highest numbered color. Okay, and if the value of xk is 0, it means no new color is feasible or possible. Here xk is not 0 as x2 is 1. So simply this piece of code will check whether the second vertex can be colored with color number 1 or not. Okay, so here the flag is 1. So I will take flag as another variable. Value of flag is 1. For j is equal to 1 to k minus 1. K is 2. So this loop will run single time 1 to 1. So value of j is 1. Okay. Now gkj, that is k is what? 2 and j is 1. 1, 2 equal to 1. Yes, 1, 2 is adjacent. Xk is what? X2 is 1 and j is what here? 1. So this is equal to 1. It means the second vertex cannot be colored with color number 1. So flag is 0. So new value of flag is 0 and immediately it will break. Immediately it will come out from the outer loop and here it will check flag equal to 1. As the flag is not equal to 1, then the control is transferred here again. Okay, and now the next highest numbered color will be generated by this expression xk plus 1. So now x2, again x2 equal to, this line will be executed, but now at this time x2 is not 0, x2 is what? 1. So 1 plus 1 mod 4. And 1 plus 1 mod 4, that is 2. Okay, so now the x2, the value of x2 is 2. So here this is 1, 2, 0, 0. x2 is 2. Now x2 is not 0. So again this will check whether the second vertex can be colored with the color number 2 or not. So for j is equal to 1 to 1, gkj equal to 1, the condition is true. xa equal to xj. Here the xk, x2 is 2 and j, x1 is 1. So both are different. So here the loop will run. The value of flag is still 1. So it will terminate. It will terminate and then control is returned to this point. Here x2 is not 0. So and k is not equal to n. So it will call m coloring k plus 1. M coloring k plus 1. So here, because this is a recursive call, so the current value of k will be pushed onto the stack. So here the value of k 2 is pushed onto the stack and the function will be called with the new value of k, that is 3. Okay. So while true, again next value k, again that function is called, but now at this time with value what? K equal to 3. So k equal to 3. See the nature or working of this for k equal to 3. K is 3. The outer while loop is an infinite loop, so the condition is true. Now x3 equal to x3 plus 1 mod 4. x3 equal to x3. So now at this time x3 is what? 0. So here it will give the value 1. Now xk is not equal to 0. So flag is 1. And the j loop, this loop will run from 1 to k minus 1, that is 1 to 2. This loop will run 2 times. So gkj means g3, 3, 1. 3, 1 is not adjacent. 3, 1 is not adjacent. Simply just here the value of j is 2. The value of j is 2. 3, 2 is adjacent. 3, 2 is adjacent. x3, k value of k is here the 3. 3x3 equal to x2. x3 equal to x2 is not, because x3 is at this time 1 and x2 is 2. Okay, x2 is 2. So this condition is not satisfied and the whole j loop will run, and still after coming this the value of flag is 1, so it will come out from this outer while loop and the control is transferred here. Now the value of x3 is updated as 1. Now the xk is not equal to 0, so k equal to n. So k is not equal to n because k is what? 3. So now it will call m coloring k plus 1. So before calling this is a recursive call, the current value of k will be pushed onto the stack and the new value of k is 4. Here the third vertex will be colored with color number 1. Now the function next value k. This is called next value k is called. Next value k is called. The k is what? K is, this time k is 4. Outer condition is true. Now x, what? x4. x4 is 0 here. So x4 equal to x4 plus 1 mod 4, that is 1. Flag is 1. The jth loop will run 1, 2, 3. Okay, 1, 2, 3. So first GKJ. GKJ means 4, 1. 4, 1 is adjacent. 4, 1 is adjacent, and xk equal to xj. x4 is 1 and x1 is also 1. So this condition is true. Flag is 0. It will come out from this loop, and outer for this for loop, as the flag is 0 and break. So, but this condition is not true, so it will not come from outer loop. Here just it will go to while true, and the next possible value of color to be generated from this expression. So here now the next is what? x4 equal to, the x4 is 1 plus 1, 1 plus 1 mod 4. The next highest numbered color is 2. Again it will check whether the 2 is feasible or not for this fourth vertex. So here the fourth vertex color is 2. So flag is what? 1. Okay, flag is 1. J loop will run what? 1, 2, 3. GKJ. K is what? 4. 4, 1. 4, 1 is adjacent, but the color is for x4 is not equal to xj. So this condition is not true. Then j is equal to 2. 2 is not adjacent to 4. Now the next j is adjacent to what? J is the value of j. Here see the j value of j is 1, then j is 2. 2 is not adjacent, then j is 3. 3 is adjacent to 4. 3 is adjacent to 4, and x4 is 2. X4 is 2 and x3 is 1. So it means कि both are not equal. So all j loop will run, and after coming this value of flag is 1, so it will come out from the outer loop. And here after coming from the outer loop, the value of x4 is 2. x4 is 2. Okay, so the control is returned to this point. Now at this point the x4 is not 0. So here if k equal to n, this condition is true now. K equal to 4. So one solution vector is generated. That is what? 1, 2, 1, 2. Okay, 1, 2, 1, 2, and then simply just here after generating this, after writing this, it will go to this outer while loop. Okay, just in outer while loop, simply just here the next value k again will be called. Means for k equal to 4, just the algorithm has tried for the color 1 which is not feasible for 4 and color 2 which is feasible. Okay, so now because it will generate all possible colors, so here the next value is called for fourth vertex again, but now the current value of x4 is 2. Okay, so here just what it does, simply x4 equal to 2 plus 1 mod 3, that is 3. It will generate what? Value is 3. Okay, so x4 is 3. x4 is not 0. Again this loop will run flag equal to 1. Okay, the loop will run j is equal to 1 to 3. So when the value of j is 1, so 4 and 1 is adjacent, and x4 is 3, and x1. x1 is 1. Okay, so both are not equal. Both are not equal. Okay, then simply the value of j is what? 2. J is 2. So 4 and 2 is not adjacent. Next again, j is 3. 4 and 3 is adjacent, but the x4 at this time, x4 is 3. 3 and 1 are not same. So simply just this condition is not true and it will come out from the outer loop and the value of flag is 1 and it will come out from the outer while loop. Now the control is transferred here. Again k equal to n as k equal to 4. So it will write the another solution. The another solution is 1, 2, 1, 3. So previous, the first solution was 1, 2, 1, 2. The second solution is 1, 2, 1, 3. Okay. Now again after writing this, the outer loop, if is there any other color for the fourth vertex? So next value k. Again the same function next value k will be called for k equal to 4. Okay. But now at this time x4 is 3 and the number of colors here, the number of colors are also 3. So it will generate x4 equal to x4 plus 1 mod 4. Okay. Now x4 is this time 3. 3 plus 1 mod 4. So 4 mod 4 is 0. Okay. Now for x4 all possible color have been tried and at the end it will reset the value 0 before backtracking. Okay. So the x4 is 0. Now here see, x4 equal to 0. This condition is true. So it will come directly from the outer loop here. Just after this, as x4 is 0, x4 equal to 0, so it will come out from this outer loop. Now this m coloring function will terminate. After termination, as this is a recursive algorithm, it will check whether stack is empty or not. Here the stack is not empty, so it will pop the next topmost value from the stack. So here the k is what? M equal to 3 and k equal to 4. Now at this time this is a situation 1, 2, 1 and 0. This is the solution vector. Okay. And the topmost value from the stack is popped, that is k equal to 3. 3. Just see, for 3 there is only one color have been tried, that is 1. Again the function is called next value what? 3. So in this way it will generate all possible colors for all the vertices and in this way generate all possible solutions. Okay. So now see, k equal to 3 and again while true this expression to be executed, x3 equal to x3 plus 1. Now at this time x3 is what? 1. So 1 plus 1 mod 4 and this will give what? Value 2. Okay. Now check whether this is feasible or not. So here just it is giving the value 2. Now check it. Flag is 1. So here the flag is 1. J will run from, as the k were 3, the j is equal to, j will run from 1 to 2. So G 3, 1. 3, 1 is adjacent? No, 3, 1 is not adjacent. So value of j is 2. 3, 2 is adjacent. 3, 2 is adjacent. X3 is 2 and X2 is also 2. So this condition is true and flag is 0. So flag is 0, so the control is transferred to the outer loop and the next possible value for the X3 will be generated. So next possible value will be what? 3. Here this is 2. This is 2 and 2 plus 1 3. So here 3. Now check it whether this is feasible or not. So yes, you can check from the dry run. Okay, it is feasible. So here this is 3 is feasible. So the control is transferred here and simply just xk equal to 0, it is not true. K is not equal to n as k is here 3. So it will call m coloring k plus 1. So before calling this, current value of k will be pushed onto the stack and the new value of k is 4. Okay, and before this our solution is 1 2 3. Now at this time the solution vector is this one, 1 2 3 0. So k is what? Here k is 4, fourth vertex, and now x4, again x4 is 0. So 0 plus 1 is 1. Now again this simply check whether this 1 is feasible or not. Now I am checking that. You see 1, here 1 is feasible or not? No. Just as 1 is adjacent to this fourth vertex is adjacent to 1 and this is also 1. So 1 is not feasible. So again the value of x4 is what? 1 plus 1. 1 is not feasible. So I will check for 2. Okay? 2 is feasible? Yes, here 2 is feasible. So simply 2, x4 equal to 2. 2 is feasible. So it will come out from this next value k, xk is not equal to 0, k equal to 4. Yes, this condition is true. So it will write another solution and the another solution is what? 1, 2, 3, 2. This is the next solution. 1, 2, 3, 2. And after it will go to the outer while loop. Now the next value k, at this time k is 4. Is there any other possible option other than 2? See, for the fourth one, x4, the current value is 2. So here 2 plus 1, that is 3. 3, and you know that, see, 3 is not feasible. 3 is not feasible, okay? And there are only 3 colors. So after that 3 plus 1, 0. So here it is 0. And when xk is 0, it will come out from this loop and the function will terminate, and again the stack to be checked whether stack is empty or not. Stack is not empty, so again the topmost value will be popped. That is the third vertex. Now the value of k is 3. The value of k is 3. Now directly you can check. See, it will call next value 3. Next value 3, and here just x3, this function, the k is 3, x3 equal to x3 plus 1, x3 is 3, 3 plus 1, 4 mod 4, that is 0. So xk equal to 0, it will come out from this loop. Here xk equal to 0. So here this is 0. And this condition is true. Again it will come out from the loop and the next vertex to be popped, that is 2. In this way it will continue and finally it will generate all possible solution vector for this problem. Now just you can check, you can trace, just it will explore the whole state space tree. Like the first one is x1 equal to 1 when the first vertex is colored with 1, and then the second vertex will be colored with 1. See, the first vertex can be colored with 1, then the second vertex cannot be colored with 1 because it is adjacent to what? 1. So this is 2, and then when x1, the first vertex is colored with 1, second vertex is colored with 2, then the third vertex. Third vertex cannot be colored with 2, then it is colored with what? 3. Okay, just first one solution, 1 2 1. Okay, and then the x4 equal to what? 2. So this is one solution, 1 2 1 2. In this way it will generate all solution vector. Okay, so now you can execute in C language, and if you are having any problem, then we can communicate via Skype or any other interactive tool.